Good morning, students, and Happy New Year. Welcome to our lesson about parallel and perpendicular lines. So we will start with our do now. We'll thoughtfully answer the question about resolutions and goals, and we're going to talk about that a lot this week as we begin our lessons. Our objective today will be to explore the slope and equations of parallel and perpendicular lines. And our essential questions ask, how do I know if two lines are parallel? And how do I know if two lines are perpendicular? So we will also watch our video, which explores parallel and perpendicular lines, and we'll complete the two assigned pages. Please pay attention to this notion or this idea of a negative reciprocal, and we'll be going over that. We will have an exit ticket where we will be asked to complete two thoughts. The first one being algebraically, using our algebra, how do we know that two lines are parallel? And algebraically, how do we know that two lines are perpendicular? Remember, when you're finished with your lesson, you turn your work in teams. Our homework will be 4.9, parallel and perpendicular lines. There are 12 problems. Remember, let's keep those cameras on, especially for our discussion at the beginning and the end of the period. Respond when your name is called at any point during the period. Submit your lesson by tomorrow morning, and if you have questions, email me. Now, a couple of notes. Wednesday is a school holiday. No school, no signing in, no assignments. Take the day off, have fun. Maybe it'll snow. It's Three Kings Day. Now, coming up, looking at the horizon, what's happening in front of us, we have a Unit 4 test, and that's going to take place over two periods. I'm thinking the 14th and the 15th of January. There is an alternative assignment or alternative assessment available. Excuse me, I've talked to you a little bit about that in class, but if that's something you're interested in, you have to do a really good job on it, and you would do that instead of the test. So email me if that's something you're interested in. Now, beginning Wednesday, January 13th, we're going to use our whiteboards. Everyone will be virtual for about 7 Wednesdays. And since everyone is going to be virtual, we're going to use whiteboards. So make sure your camera is working because I'll need to see your whiteboard. Make sure you have a whiteboard and a dry erase marker. I've given those out. If for some reason you don't have those, please email me, okay? So here is our do now, and Happy New Year. So it is said that goals and resolutions go hand in hand. While the resolution is the theme of the change you want to make or the direction you want to take in your life, the goal is the specific steps that you take to fulfill your resolution. Why should you set specific goals when you make resolutions? So let's think about that. And I think about, for me, I've certainly gained some weight during our pandemic lockdown. So I need to take that weight off, and plus other weight I need to take off. I just need to lose weight. So if I just say, gosh, I want to lose 40 pounds, well, that's going to be a hard thing because that's a lot of weight to lose. But maybe if I say, I'm going to lose 10 pounds, before Valentine's Day, and then maybe I'm going to lose 10 more pounds before the last day of winter, March 21st. And then I want to lose 10 more pounds by my birthday on June 3rd. Well, that's a lot more achievable. And that is something that, maybe I'll stick with it. So 10 pounds, and I'm going to do that by Valentine's Day. And 10 pounds, well, let's make my plan. And we'll do that by the end of winter, which I believe is the 21st of March. And then 10 pounds by my birthday, which is June 3rd. Then I can plan on losing the next 10 pounds over the summer, maybe before September 1st. Well, you know what? That's doable. I can do that. I think, and if I have a mistake or I don't do so great, I don't have to beat myself up. And I can say, you know what? Let's just worry about 10 pounds. I can do that. So I really think that specific goals and breaking up those goals is really helpful. Now, not all resolutions are about getting healthy and losing weight. You might have a resolution of, doing your homework on time or understanding your classes better or spending more time with friends, maybe you actually using the phone instead of texting, or FaceTime to talk to people. Those are your goals. So I want you to think about this carefully, and I want you to write something down and show that you've put a little thought into it. This is important. There is our exit ticket. We'll get back to that. So today, our topic is parallel and perpendicular lines. Okay, and I'm calling this lesson 4.9. So, what are parallel lines? Well, by definition, parallel lines are lines that never intersect. So they don't cross each other ever, right? Train tracks, you've learned that when you were younger. Now, what do we know about parallel lines? Well, parallel lines have the same slope. And that's the algebraic definition. They have the same slope. Okay, so let's look at a couple of equations. Y equals 3x plus 4, and the slope here is 3. Or we could have y, these are in slope-intercept form, y equals 3x minus 2, and again, the slope here is 3. So these lines, these two equations have the same slope, where m equals 3. So that's your definition for parallel lines, and here they are. This is what they look like. Perpendicular lines are lines that intersect at 90-degree angles. And here we have some perpendicular lines, and we could actually put the symbol for a 90-degree angle right there, and that would still be correct. So now algebraically, how do we know that two lines are perpendicular? Well, they have the negative or opposite reciprocal slopes. Another word I could use here is opposite. So let's think about this slope of 3 in our prior example. In this case, we could say y equals 3x plus 4, and our slope is 3. But if we want to show the perpendicular equation, so the negative reciprocal of 3, well, we can think of 3 as 3 over 1. So the negative reciprocal would be negative 1/3. So that would be y equals negative 1/3 x. I can give it any y-intercept I want. Let's do minus 2, like we did on the other one. Okay, so these two equations, this example right here, are perpendicular lines. Let's take a look at Desmos, okay? And let's take a look at this kind of in action, so to speak. So we've got here the equation of y equals 2x plus 3 in red. We can see that it crosses the y-intercept at 0, 3. We can see that it has a slope of 1, 2. And an easy way to look is to find this point here, and we count a rise of 2 and a run of 1, and that's a slope of 2. Well, let's also show y equals 2x minus 4. In this case, we have a y-intercept of -4, and here it is right here, 0, -4. We also have a slope of 2. Let's find, there we go. So if we count a rise of 2 and a run of 1, it's a slope of 2. And you can easily see that these two lines are parallel and they will never cross each other. They will go on to infinity, and they're just like those railroad tracks your math teacher told you about when you were young, when you first learned about parallel lines. Now, let's think about reciprocal lines. I'm going to turn the second equation off. And the negative reciprocal of 2 is -1/2, and that's this green line of the equation there, the green graph. So we have y equals -1/2 x plus 3. We're still crossing, in this particular case, we're crossing the y-intercept at 0, 3. That same y-intercept, but these lines, we could, if we were able to draw the symbol for a right angle there, because these lines exactly have a 90-degree angles between them. Now, let's add back in the y equals 2x minus 4. There it is. And you'll see that the green graph is the negative reciprocal, or is perpendicular to both the blue and the red graph. So because the blue and the red graph have the same slope, that slope of 2, which we see in their equations here and here, the green line with the negative reciprocal slope of -1/2 crosses both of those lines. So let's put that into practice ourselves. The first thing we're going to do is just look at some examples of negative reciprocals. It's definitely worth looking at. So a negative reciprocal of 3/4 would be -4/3. The negative reciprocal of 2, as we've already shown, is -1/2. Now, if you already have a negative, the negative reciprocal will be positive, okay? So we're looking at positive 8/7. And in the case of a slope of 1, a negative reciprocal is -1. In case of a slope of 0, remember 0 is a horizontal line. So the negative reciprocal of that would be undefined. And that would be our vertical line. So what is a way to remember a negative reciprocal? I'm going to erase a little bit here to give us a little bit of room. And we're going to write, it is a fraction flipped and the signs are switched. Flipped means we are showing the reciprocal. Okay, a fraction flipped and the sign switched. Okay, so we have different ways that we determine whether sets of ordered pairs or whether lines are parallel, whether they're perpendicular or neither, and which is what we're going to do. We're going to determine if these segments are parallel, perpendicular, or neither. So first we're going to look at when we are given ordered pairs. So we have these ordered pairs, and we're going to determine if the segments, in all cases, they are being named A, B, and C, D, and we're going to determine if those are parallel, perpendicular, or neither. So what are we going to use? We're going to use the slope formula. Which I know you've memorized by now. In all cases, we're going to consider the first ordered pair as our x1, y1, and the second ordered pair as our x2, y2. So we have AB formed by -2, 3, and 2, 6. So let's find the slope. We have to find the slope of those two ordered pairs. So first we work with AB, line AB, that's how we write it. We write M equals, and that would be 6 minus 3 divided by 2 minus negative 2 is 2 plus 2, which gives us a slope of 3/4. Now we'll work line CD, and I think what I want to put there is, I don't think the equal sign is appropriate. I think I'm going to put a colon, and then M equals, it will be 3 minus 0 divided by 3 minus negative 1, which is plus 1, which will also is a slope of 3/4. These two have the same slope, both of them. M equals 3/4. So those two lines are parallel. All right, let's move on. For number 2, AB is formed by 0, 2, that's our x1, y1, and 5, 4, that's our x2, y2. So let's find the slope of AB. So M equals 4 minus 2 divided by 5 minus 0, which is a slope of 2/5. So M equals 2/5 for this first set of ordered pairs. Now let's work with CD, line CD. M equals 3 minus 8 over 3 minus 1, which gives us a slope of negative 5 over 2, and that is the negative reciprocal of 2/5. So in this case, M equals negative 5 over 2. So those two lines are perpendicular. All right, let's look at the next two. We'll start with AB. Line AB is formed by negative 1, 8, 2, 6. So M equals 6 minus 8 divided by 2 minus negative 1, which is 2 plus 1, which, when simplified, equals negative 2 over 3. So here our M equals negative 2 over 3. And let's do line CD. M equals 3 minus 2 divided by 3 minus negative 1, which is 3 plus 1, and the slope is 1/4. Well, there's neither a negative reciprocal relationship, nor are those the same. Therefore, if we were asked a question, remember, parallel, perpendicular, or neither. In this case, the answer is neither. They are neither parallel nor perpendicular. So let's look at number 4. We'll start with AB. So our M equals 4 minus 3 divided by negative 1 minus 2. Don't forget your integral rules. So that would give us 1 over negative 3. So our slope here is negative 1/3. And let's do line CD, which is 6. Oh, forgot my M equals. Let's do M equals. Keep our work nice and straight. 6 minus 3 over negative 4 minus negative 5, which is plus 5, and that evaluates to 3, and a positive 3 and negative 1/3 are certainly negative reciprocals of each other, so those points are perpendicular. And I hope you're going to try to do the next 4, maybe without me, and let's see how you do, and then come back to the video. Okay, so let's continue evaluating these points for slope. We have line AB, which is formed by 0, -2, 0, 7. So this will be 7 minus -2, which is 7 plus 2 over 0 minus 0, which gives us a slope of 9 over 0. If we have 0 in the denominator, that slope is undefined. So if we have either if we have an undefined slope for CD, then we'll have parallel lines. If we have a slope of 0, we will have perpendicular lines because undefined and 0 are negative reciprocals of each other. So let's evaluate CD. M equals -5 minus -5, which is -5 plus 5, over 6 minus 3, which evaluates to 0 over 3, which is 0, and a slope of 0 and an undefined slope. Those are negative reciprocals, and those lines are perpendicular. Let's look at number 6. We'll evaluate -4, 7 and -2, 6. So line AB and M equals 6 minus 7 over -2 minus -1, which is -2 plus 1, which simplifies to -1/2. And now we'll evaluate CD. M equals 3 minus -2, which is 3 plus 2, over -8 minus 2, which equals 5 over 10, which simplifies, -10, which simplifies to -1/2. And it looks like these two have the same slope, so they are parallel. Well, number 7. Let's start with AB. So M equals -4 minus 1 over 3 minus 3, which simplifies to -5 over 0, which means this is undefined. It is a vertical line. Let's look at CD, line CD. M equals 5 minus 1 over -4 minus -4, which is -4 plus 4, which equals 4 over 0. And again, 0 in the denominator. That is an undefined lines. These are vertical lines, both of them, and they are parallel because they have the same slope. And finally, let's look at number 8. So AB is formed by -3, 8, and 3, 2. So that would be 2 minus 8 over 3 minus -3, which is 3 plus 3, which evaluates or simplifies to -6 over 6, which equals -1. So we have a slope of -1. The second set of points, line CD, we'll evaluate the slope. -1 minus 1 divided by 5 minus 7, which equals -2 over 2, -2 over -2, which simplifies to 1. These two are the negative reciprocal of each other, so these lines are perpendicular. Remember to always show your work. Oh, I don't know what happened there. Perpendicular. Okay, now, these are highly tested areas. Everything in today's lesson, highly tested areas. Now, sometimes you won't be given points. You will be given equations. So you need to have your equation in slope-intercept form. So you want to look for slope-intercept form, because slope-intercept form allows you to easily identify the slope. So y equals mx plus b. M is your slope. So number 9, we have y equals 7x plus 2 and y equals 7x minus 1. Well, let's evaluate for slope in the first equation. And if we just look at this, the slope for the first equation is 7. The slope for the second equation is 7. So those lines are parallel. So we're good to go with that. Number 10, y equals 4/5 x minus 8 and y equals negative 5/4 x plus 3. In the first equation, our slope is 4/5, and in the second equation, our slope is negative 5/4. Those are the negative reciprocal to each other, so those lines are perpendicular. Now, let's look at number 11. We have y equals negative 1/3 x plus 2. The slope is negative 1/3. In the second equation, even though we don't have a b value here, it's still slope-intercept form, y equals 1/3 x, so our slope is 1/3. Okay, don't be fooled by this. These equations, these lines, are neither parallel nor perpendicular. Okay, in order for the second equation to be perpendicular to the first one, we'd have to have a slope of 3. 3 is the negative reciprocal of negative 1/3, not 1/3. So this is neither. And I would recommend that you go to Desmos or a graphing calculator if you have that. Go ahead and graph them, and you'll see that those they're neither parallel nor perpendicular. Now, 12, 13, and 14. For these 3 problems, you are not given the slope-intercept form. These 3 problems are in standard form. So if the problem is in standard form, you must convert to slope-intercept form. Okay, that's your first step. So you have a bit of algebra to do. So we're going to move x to the other side of the equation, which will give us 6y equals negative x plus 30. And remember, I like to put x as the first term on the right because I'm looking for that slope-intercept form, y equals mx plus b. And if I divide both sides by 6, I end up with y equals negative 1/6, because we have here, I just want to remind you, we have an invisible 1 here, okay? Don't forget that. So y equals negative 1/6 x plus 5. So our slope here is negative 1/6. Now let's change our color for the second problem. We simply need to divide everything by 3 here. And y equals 6x minus 2. In this case, our slope, is 6. And negative 1, 6, and 6 are negative reciprocals of each other, so these lines are perpendicular. Let's look at number 13. So we'll move 5x to the other side. That gives us negative y equals negative 5x plus 4. We'll divide everything by negative 1. An invisible 1 there. That will give us y equals 5x minus 4. And our slope here is 5. In the second equation, we already are in slope-intercept form. So we've got a slope of negative 1/5. Negative 1/5 and 5 are negative reciprocals of each other, so these lines are perpendicular. Let's look at number 14. So I'll move 3x to the other side. I like to put it right there. So I will have negative y equals negative 3x plus 2. I'll divide everything by negative 1. So I can isolate that y. Y equals, now negative 3 divided by negative 1 is 3. Y equals 3x minus 2. And our slope here equals 3. And I'm going to move for the 12x to the other side of the equation, which will give me negative 4y equals negative 12x plus 4. I'll divide everything by negative 4, which leaves me with y equals negative 12 divided by negative 4 is 3x minus 1, and the slope here is 3. So we've got a slope of 3, same slope. These lines are parallel. Now the last two problems of the day. Both of these, number 15, are in slope-intercept form. So the slope for x is 1. We have an invisible 1 there. So m equals 1. We also have an invisible 1 here, but we've got a negative sign in front of it. So the slope here is negative 1. 1 and negative 1 are negative reciprocals of each other. So these are perpendicular lines. Okay, let's work with number 16. Now look what we have here. Y equals 6 and x equals negative 1. Let's take a look at Desmos. So I've got y equals 6, which is this purple equation, this purple line here. That is a horizontal line. The horizontal line has a slope of 0, which makes sense because there is no x value. So here the slope, well, let's just first say x is 0. There is no x, so the slope is 0. Now let's look at x equals negative 1. And x equals negative 1 is this orange line here. Okay, there's no y value. This orange line is a vertical line. A vertical line is undefined. So we have no y value. We have 0 in the denominator. So the slope on x equals negative 1 is undefined. If we have a 0 and an undefined slope, those lines are perpendicular. And let's take a look at that graph one more time, and we can see the purple line and the orange line are indeed perpendicular to each other. So keep an eye out for that. Again, this is a highly tested area of algebra. You'll see lots of problems like this. Okay, so let's finish our exit ticket today. So algebraically, how do we know two lines are parallel? We know that they're parallel because they have the same slope. Put a little emphasis there. And algebraically, how do we know two lines are perpendicular? They have the negative reciprocal slopes. Now let's put a few examples there before we finish. So same slope would be y equals 4x minus 2 and y equals 4x plus 25. Okay, they have the same slope of 4. Negative reciprocal would be, if we take the same first equation, y equals 4x minus 2, well, 4 can be thought of as 4 over 1. The negative reciprocal of 4 over 1 is negative 1/4. So the perpendicular equation would be y equals negative 1/4 x. And we can have any y-intercept we want. Let's put that plus 25 in. And now these two equations are perpendicular. So work hard. You've got 12 homework problems tonight along the lines of what we've just done. You can rewatch the video. Remember, let's make a New Year's goal to really stay on top of the algebra. It will serve you well all through high school and beyond. Thank you very much for your hard work today. I'm really proud of you. And as you continue to work hard, I know you'll get it, and I know you'll be great.